4.3, problem 4. Find the critical numbers of the function as shown and classify them using a graph. To find the critical point, first of all, we need to find the first derivative of this equation. So it will be fx equals to this. So to find the critical point, we need to let the first derivative of this equation equals to 0, which is and we need to do a further factor. So to let this equation equals to 0, we can divide it in two parts. This is the first part, this is the second part, and we can let any of those part equal to 0. We'll let the whole equation equal to 0. So first of all, let the first part equal to 0, which is 60 times x squared equals to 0. We can solve that x equals to 0 and let the second part equal to 0. It will be a quadratic equation. We need to use the formula to find out the root. The x will equals to minus b and the square root of b squared minus 4ac over 2 times a. It will equals to this. So we have already know this all of 3 critical point of this equation. We need to use the graph to classify them. We can use the critical point to divide the whole graph into different intervals. The first interval will be the negative infinity to the second part will be the first critical point to 0, to the because 0 also known as the second critical point. Third part will be the second critical point to the third critical point, which is the 0 to the fourth part will be the third critical point to positive infinity, which is so after divided them into different interval, we need to plug in some test value to find out the sign of the derivative of fx. We can plug in the minus 1. This is the value between the negative infinity to the first critical point. And the result of the sign is positive. On the second interval, we can plug in the negative 0.1. And after calculation, the sign is negative. In the third part, we can plug in the 1, and the sign will be negative. At the fourth part, we're gonna plug in the 4, and it's gonna be positive. So the conclusion will be, because this is first of all, this is a positive sign and then a negative sign. So the graph should look like a concave, down. So like this. So it's have a local maximum. On the rest of the two part, the graph first have a negative sign, then turn into positive sign. So decrease at first, then increasing. So the graph looks like this, which is concave up. So it will have a local minimum value. And on the second critical point, which is 0, we can show the two range the range between 0, it all have a same sign, which is negative. So the 0 is neither local max or nor local minimum. Our final answer will be x equals to is local max, x equal to 0 if neither x equals to 3 plus is the local minimum.